Hi everyone, I thought I'd give you an update on my research as I haven't done one in quite a while. I have some spuds planted in the ground here, well quite a lot of spuds. Hang on, let me turn the camera around, you don't need to look at my big bald red head. The potatoes, so we have 6 rows of potatoes. The outside rows are gourd plants on both sides, and then we also have some gourd plants that go all the way around and through the middle of or between each block. So we have 6 blocks, each of which, well, 3 of them are controlled by their own irrigation line, like this one here. You can see that it goes off there and that one goes all the way up there. So this is a independent loop, this block here, and then these 2 blocks are connected because these are both going to be well watered blocks. So they have a shared loop which they also share with the first block up there, and then these 2 blocks also have independent loops. See, that one goes there and then up to the top, doesn't connect to anything else. As with this one, you can see they all end there, and then that one comes down here and all the way up to the top. So the rationale behind this is we have 3 well-watered blocks where the irrigation is going to be on basically all the time. So these are going to have loads and loads of water, they're going to be nice and happy, you're going to produce a very nice big yield. Then the other 3 blocks, which are all independent, are going to have their irrigation controlled by temperature probes which are in there. So if we take these 2 blocks as an example, because they're next to each other and I'm already here and I can't be bothered to walk all the way back down there, we'll have temperature probes on a couple of plants in this block, temperature probes on a couple of plants in that block, a couple of plants in that block, and when the temperature in this block is a certain amount higher than the temperature in this block, it will trigger this block to come on. The rationale behind that is that plants use water to cool themselves down. If there's not enough water, the plants won't be able to cool themselves down, the temperature will go up, and that will trigger the water to come on. So the idea is that the plants will only be getting water when their temperature suggests that they require it. That's the logic behind the whole thing. And we'll have 3 pairs, so we'll be able to analyze it statistically, and we'll be able to compare the amount of water used in the different blocks, because they all have the same number of these little drippers which have a given flow rate. So each block has, I think, 42 of them, 7 for each line, and then we'll be able to multiply that up, and I can't do it in my head right now, but we know how much water each of the well-watered blocks is getting, and then based on how long the water restricted or the temperature controlled irrigation blocks are on for, we'll be able to work out how much water they've had. So hopefully we'll see a significant saving in water and an insignificant difference in yield. That is not the aim, because obviously this is science, so I'm not trying to fudge anything, but yeah, that would be nice if it came out like that. It might be that we have a significant water saving with only a mild but significant yield loss, which would also be a good result. So yeah, that is what I'm up to. Oh, look at that. Yeah, that's what I'm up to this summer. Oh, let's go and have a look at the other ones, because this is still quite a short video. I haven't waffled too much. Hopefully that all made sense. God, I really am red. I need to get some sun cream. Blimey. Right, over here, a bunch of pots. 2 different sizes. Some of you may have seen my previous videos on my pot size experiment, which is the first experiment I did at Reading, and I'm now repeating it 3 years later with the help of a Europe student, which is like a placement thing that the university do with undergraduates that come and help PhD students like me. We have 30 big pots and 30 little pots, and each of these is split in half between Maris Piper and Charlotte. So I think these ones are Piper, those are Charlotte. Same layout for all of them at the moment. We'll switch them all up a bit later on once they've actually emerged, because there doesn't seem to be any emergence gradient or anything, so because they're outside and they're all in pots, so I don't think the order effects are going to be particularly strong yet. But yeah, we're going to have, if I come down here, show you the labels, we're going to have a couple of different irrigation regimes. So we've got irrigation regime 1, irrigation regime 2, and irrigation regime, can you see it? Let me zoom, 3. Yep. Oh, I need to turn that off, I think. And yeah, so the idea here is that the well-watered pots aren't particularly well watered if you have pots that are small enough, because the volume of the pot is not sufficient to hold enough water to stop the plants from being drought stressed over 24 hours. So regime 1 will be a single watering per day, which is kind of the standard, but I believe is insufficient, particularly in small pots. Number 2 will be a drought protocol, which will be the same one as I used in my first pot experiment, and then number 3 will be like a continuously watered, or maybe like a couple of waterings a day to really try and actually get a well watered sample. And then what I sort of predict will happen is that the single daily watered pots will be more like the drought stress pots than the actually legit adequately watered pots, at least in the smaller pot size, and then that effect hopefully will be smaller in the larger pots as they have a larger volume. They're able to store more water throughout the day, so hopefully we'll show that the 5 litre pots are too small to prevent drought stress even in well watered pots, unless maybe you water them a couple of times a day, but hopefully 20 litre pots will be big enough to hold enough water, so you only need to water them once a day. If not, then the twice daily or 3 times, or whatever we decide to do, daily irrigation should be enough. So that's that. God, every time I turn the camera around, I'm surprised at how burnt I am. Anyway, that's a very rambly, waffly, zero cuts, badly explained overview of the research I'm doing this summer. Hopefully it made sense. I'm sure it didn't. So feel free to ask me anything that you were confused by, which I'm sure is a lot, in the comments, and I'll do my best to get back to you. Yeah, hopefully I'll be doing another research profile video soon. I really want to pursue that. That's kind of what I want to do after the PhD is finished, science communication stuff, so I'm going to try and make another one of those soon. I have one written and ready to go. I'm just waiting for the person who's starring in it to have some free time to shoot it, and then I'm writing another one now, and I'm also going to try and do some YouTube short stuff and TikTok-y stuff maybe as well, even though I am certified old, as you can tell. Yeah, so that's that. Thanks for watching, and I'll see you in the next one. Peace. I should do that at the end of the research videos, really, shouldn't I? Yes. Bye.